All right, so I wanted to talk about GeoDjango and a little trick that I found to get it to work with Zappa, which is a way to run code on AWS Lambda, kind of in a serverless, quote, buzzwordy thingy. Can't really talk too specifically about GeoDjango or Zappa because of the time, but if you've used it and you've been waiting for this, I finally found a comment after repolling every couple of months, and somebody said, hey, there's this way. And so I wanted to spell that out and kind of put a bow on it. So if you add raster.io, which is a geographic library for dealing with raster or kind of traditional image data, to your requirements file, and then this version is important if you want the paths that I specify to work. Go into your settings file and specify your GOODL, or Geospatial Data Abstraction Library, and GEOS, or Geometry Engine Open Source libraries as these. Update the Zappa function, you will begin to be able to do GeoDjango queries as long as you have a spatial database. PostGIS is best, and you can get that on RDS with their Postgres version as well. SpatialLite would work. Just don't do SpatialLite because that's an S3 database backend. Now, in a real world, you would not want to do this because it won't run on Docker or locally, so use environment variables. There's a downside to this approach that is great for hacking projects, not so great if you're trying to port your app. It does cost about 20 megabytes over if you manually manage your dependencies, which I'll post some info on later, but you have to, basically the short version is intercept the code package via Zappa package or by just copying the file before it gets uploaded, extract all the data, and then pull them into your own repository and upload them. Now, if you use Slim Handler to get around that limitation, there's a 75 megabyte restriction for Zappa, then your paths will change. It will be in temp instead of in var task, and it will also be based on your project name, still in the raster.io.libs folder. If you are unable to find them or you change versions of libraries, go back to the GitHub issue and use the Zappa invoke command that they specify. Was that my time? Oh, okay. I thought I heard a dinger. Okay, so we had a few extra seconds because the adrenaline got me talking fast. And so we'll talk about GeoDjango. If you want to use GeoDjango, you can do things like, sorry for the small text, like line 11 would take all objects in the database and annotate a distance onto it so that I can see how far they are from the point I specified. And then we order by the distance. And then we're able to display geospatial data. This is really cool for finding where things in your data are close to other things. You know, searching for stores or locations or any of these sorts of things are all really useful. And then I guess we've got a little bit of extra time, so we'll talk about Zappa. There's a bunch of DjangoCon talks that are really useful on that you can find on the DjangoCon YouTube channel, which will have posts from all of the talks from this year, including closed captioning, within a couple of weeks. And so serverless still requires servers. It's a compatibility layer so that you can run on serverless with Lambda, but not have all the lock-in. And most applications can run inside the free limit, which is kind of cool for hacking projects and learning stuff. You can pip install Zappa, Zappa init, Zappa deploy, take that URL, drop it in allowed hosts, Zappa update, and then you're done. Thanks.
All right, so we're going to get started with Django and exoplanets. Marshall, are you ready?
Yeah.
All right. Please begin.
All right. So this is me. I'm Marshall Sutton. I work at NASA's Goddard Space Flight Center in Greenbelt, Maryland. Everybody wants to know what we do at NASA. All right, how do I do the next one? There we go. So a little bit about me, a software engineer. I'm very new to Django. I was working on some earth science applications and this laser validation GUI set up there. That job ended. My boss came up to me and said, hey, do you want to work on this other project that involves Django and web programming? And I was like, sure, just send me to DjangoCon and I'll do it. So that new project is called the Exoplanet Modeling and Analysis Center. It's a website. It runs on Django. And it's a clearinghouse for different scientists to showcase their work and to present models. And some of them are interactive. My coworker, who is here somewhere, Apeksha Patel, actually worked on the CSS for this. It's a pretty basic website. We've got forms. You put in some of the characteristics of your exoplanet. How big is it? Sorry, it's a little small. I can't even read that. Your size in terms of Earth radii. How hot it is, and you get some characteristics back about the chemical composition of your exoplanet, and so this nice graph. Our job is to be format agnostic, so whatever model the scientist comes and brings it to us, it's our job to integrate it into the website. So sometimes they come in the form of C++ or Fortran code or whatever the scientists like to use. And then part of my job is to make these plots. What is an exoplanet? An exoplanet is a planet that's orbiting another star other than our own. How do we find the exoplanets? You can't really see them with visible light, so with the naked eye, away from a telescope, so we use these light curves. As the planet goes in front of the sun, it dims the light a little bit, and so if we look at the star long enough and hard enough, we can see these patterns. That works well for very big stars and stars that orbit closely to the sun, but that's how the first ones were found. What are scientists interested in? They also want to look at the spectra of these exoplanets. This is the wavelength on the bottom. It goes from ultraviolet to near infrared, visible in there. And we're just seeing what kind of radiation we would get back from an exoplanet. They model what a planet would theoretically give off as radiation. And they want to know if we tweak some of those parameters, how is that going to change the spectrum? So that's the blue versus the red. What happens when we tweak the temperature of the planet by a few hundred Kelvin? Some NASA exoplanet missions. This is the first one's TESS, Transiting Exoplanet Survey. It's got 4 cameras inside that little box. I keep moving my cursor. I don't know if it shows up. Okay. I'm thinking now will point out. So there's the 4 cameras. It just stares at stars looking for those variations in the light curves. And that was managed out of Goddard. So that's what's looking at exoplanets now. In the future, on the right, we have the James Webb Space Telescope. That was built at Goddard. It was actually assembled in the building. You could go in and see it being built. It's got an 18-meter segmented mirror that folds out and unfolds. There's a sun shield the size of a tennis court. It's quite an impressive bit of machinery. Check it out if you can. It's supposed to be launched in 2021 or sometime thereafter. Anyway, how many exoplanets have been found? I wanted to look at the number, but there's 4,000 exoplanets. There's 3,000 ones that they think they found. I was reading that the number of exoplanets that we discovered doubles every 27 months. So apparently that's the new Moore's Law. So that's it.
Hi everyone, I am Daniele. I want to show you the world's cheapest and simplest pen plotter. Just in case you don't know me already, I work at Devio. We do cloud hosting for web projects for people who don't like to cry about deployment. So if deployment makes you cry, come and talk to me about that. I'm very happy to offer you a remedy. And you can talk to me by coming to find me or by finding me on the internet. So my question was, what is the cheapest, simplest pen plotter that could possibly be made? And I made it. And it's called a brachiograph. Brachio meaning arm, and grapho to write, from Greek, of course. And It's made of 2 arms with 2 joints and many triangles. After a while, you realize that everything is made out of triangles. Here is the representation of it geometrically and what it actually looks like doing something. You can see it's made from sophisticated materials like clothes pegs. Here's the mechanism for lifting up the pen or the pencil when it's drawing so that it doesn't make a mark on the paper. Here's the mathematics. It's not rocket science, but it's 30-year-old high school trigonometry, so it might as well have been rocket science as far as I was concerned. The bill of materials, very cheap. The Raspberry Pi Zero, by the way, everything runs on the Raspberry Pi, $5. The 3 servo motors, about $3 each. The rest of the stuff, you can find, actually, all of it is so cheap that even if you were to steal it, you'd be very unlikely to get punished or punished severely, simply because the cost of punishing you would be so much that it wouldn't be worth it. So when you're dealing with low-cost things, actually, you can get away with quite a lot. The tools, a ruler and a knife. If you need it, it's always handy to carry a knife. You never know when your enemies are going to be around. So what I do, I've got a routine as well to vectorize the images. I start with a photograph, I vectorize it, and then I draw it, in this case with charcoal, or with a soft pencil. This one is a pencil again, and this is hatching as well as drawing the outline, so I've got 4 levels of grayscale in that. And again, the charcoal. I like the charcoal very much. I like the effect it has. Everything's on GitHub, and it's pretty well documented. So if you want to take a photo of that, where you'll find it. I'm going to try and get the video on here. How much time do I have left, Kojo? 2.5 minutes.
When I stand up, you'll have 1 minute.
Yeah, no, I'm going very well. Okay, so you'll have to come and get that for me later. I'm going to come out of here now, and I'm using FaceTime to fake this. It's kind of a poor man's video camera, so yeah, now. So this is the machine. Where's Calvin? Calvin, help me out in EuroPython when I had 3 people on stage holding cameras and typing with special keyboards. So you can see it working here, I hope. It's me, isn't it? It's very handsome. I use that photograph not because I'm a narcissist, but because it's actually quite easy to draw and it comes out well. So you can maybe see the pen going, the pencil in this case going up and down there with the 3rd servo motor. Oh, it's drawing the line, so it's not bothering to go up and down. But I think you get the idea. It's made out of little sticks there. You can do it also with stiff card, but then the advantage with the sticks rather than the card is that if you use card, you have to cut the card. So this way you don't even need a knife. And these servo motors are the cheapest you can find. You can find cheaper ones, but they're probably counterfeit and will stop working. If you use better motors, you get much more accurate results just for a couple of dollars more. But I think it's quite fun to see these low resolution results. Let me just show you a couple of other pictures down here that I did earlier. Oh, I think you've seen these pictures, so there is one. Sorry? I want a whole minute. What am I going to talk about? Oh, there's a... so I'm not the greatest cameraman. I do my own sound at the same time as well. So it's, it's really easy. You can build the whole thing in 45 minutes or so, and most of that time will be spent getting the glue off the kitchen table. So I'll have it set up again out there. I'm going to be doing some sprinting on it perhaps over the next couple of days, if anyone's interested. Maybe making a Django interface so you can upload images and do it through a nice graphical interface. But come and talk to me about it. Thank you very much. It's been a really lovely conference.
Okay, hello everybody. I'm Rodrigo. I'm talking about ChatGPT and how we can make a simple solution using Python. I came from Uruguay. I work as a full stack developer and Octobot. In Octobot, we really love Django and Python. And this is my first time speaking in English for a large audience, so please have mercy. As you know, internet is a risky place. There are so many data stolen every day. Also, as users, we need to manage many apps and many accounts. So we need to remember so many passwords. And sometimes, but only sometimes, we use the same password between different accounts. This is not safe, so we need to keep up safer using another factor. So we need a two-factor authenticator. So first of all, we use a password, and another factor could be a code that an app can give us. So maybe you just use Google Authenticator. As you know, to enroll an account, we need to take a photo to a QR image, and then the app gives us a code, some numbers that change by the time. But what are these numbers? What are under the hood? It's TTP, time-based one-time password. To sum up, TTP is a hash function that return us a token. We need to pass a secret and a count. The secret is generated by the backend, and then we need to share with the client. And the counter is the current time. So, for a moment, the function returns us a token, and it will return the same token for a period of time called interval. After the interval, the function returns another code. So, if the backend and the client generate the same token at the same period of time, and the client could send the token to the backend to verify, we are done. So, let's do this with a great library that is by OTP. It's very simple. Use it. The code is very simple. We just need to import the library. Then, as I said, we need to create a secret. The library has a method to create a secret, but you can create it in another way. Then we need to initialize the OTP object with the secret. By default, the interval that I say is 40 seconds. You can change it if you want. With the function, but now the TTP returns us a code, a token, and we can verify with the function verify. But this token is valid for 30 seconds. So if we wait 30 seconds and then we validate this token again, the function will return false. So this is the base code, and we not need more, but there are one more step. We need to create the URL. We need to share the secret, as I say. So in that point, maybe we just have the user username and an issuer. So the library has another function called provisioning URI. So we just made the URL that start with the protocol OTP auth. We can use a simple front-end library to embed the URL, and with the Google Authenticator, we take a photo to the QR image, and we can verify in the app the new code. So with the new code, we can verify with the backend, and that's it. Thank you.
Hi guys, so my name is Nicole, and I did a presentation here on Monday about internationalization. This is my first DjangoCon, and I'm really happy to be here. This lightning talk is actually nothing really related to Django or Python, but it's something that I apply on my day-to-day basis, and it helps me out on my work with using Python and Django. So that's why I figured out that I should show this to you guys. Basically, I'm going to talk about how to get organized with bullet journal. Bullet journal is a methodology created by writer Carol. I'm not sure if I'm pronouncing it correctly, but they describe it it is described as a mindfulness practice, but actually disguised as a productive system. And the basic goal is to help need to do while remaining mindful of why you need to do that. And bullet journal is basically reading in rec logging, what they call it, which is just a way of capturing all the information as bullet lists. So the first thing that you do when you have a new journal is to define the syntax of your bullets, which we call the key of your journal. And you can get as creative as you want. With this one, you usually put this on the first page of your journal, just to indicate what's the syntax for a task. And a task is the thing that you have to do. Then you can define another syntax for just a note, which is just something that you don't want to forget. And you can create another syntax for events that are some noteworthy moments in time. So you can put a square, just an actual bullet, a star, an arrow, anything that you feel more comfortable with. But why am I talking about writing on a paper in 2019? I know that we have a lot of applications out there that can help us to create bullet lists. Like you can get Evernote, you can get Google Keep. It's going to give you bullet lists. It's not a big deal. But actually, we have studies showing some benefits of writing something down by hand. It can improve your memory, like when you write down, at least it happens for me, I don't know if it happens to you guys, but it actually helps me memorize better what I need to do. So whenever I write down using pen and paper, I feel that I remember better what I need to do. For me, it's also kind of a stress relief. Whenever I take some time to organize my journal, I go over everything, and it's nice. It gives me a nice feeling of laying down and listing out everything that I need to do, and then I can have this clear vision, and I can take a breath and know that I can accomplish this, or forgive myself that I won't be able to do that. So it's just a nice way of getting rid of all that mental rush that we get. Oh, I have so much to do. And then when you list it out, writing, taking your time, maybe practicing some calligraphy, you can see that, hey, it's not that much, and some of those I don't really have to do, so it's really nice. It works wonders for me. And also, it enables your creativity. When you have paper and pen, you have so much freedom. You are not limited by your mouse or your keyboard. You can just go ahead and do whatever you want. So this is my favorite part of writing on a paper. So I hope that you guys have noticed that in your bag you received this planner from Labcodes. That's a company that I work for, and he's just an example of how you can use the planner to organize your week. So this is my planner for this week. I took some notes of some talks that I wanted to see, some social events that we had this week, and I'm looking forward for spring snacks days. And on Saturday, I'm going to go San Diego sightseeing around the city, so I put that down there. So I hope you guys enjoy it, and I hope you guys use this planner on your day-to-day basis, and it helps you as much as it helps me. Thank you.
To make a student newspaper with someone you may have seen earlier today, and I did a terrible job, sorry about that. And then I tried to study some organization around PTC, and my supervisor thought that was a terrible idea. And then my best friend from middle school showed me a documentary about bulletin board systems. So, hands up if you've heard of bulletin board systems. Okay, so much larger percentage. If you're interested in bulletin board systems, look up FidoNet. And it's actually got a whole episode in this documentary. Anyway, that's one way to figure out what to study for a thesis. And the dude I then got into contact with put me in touch with the records he had of old FidoNet node lists, which included all the telephone numbers you could call. And they tried to keep them updated every week. So that's where my terrible title comes from. And so Tom Jennings is the dude who, one of the main engineers who I worked with in the beginning. That's where his little ASCII logo comes from. I definitely spelled that word wrong. But here is my attempt at an XKCD diagram of the motivation behind FidoNet, which was bulletin board systems were very much individual networks. Someone would volunteer to run one, but if you wanted to call someone outside your local network, you'd have to pay long distance charges. That was really annoying. So Tom Jennings had a friend, I think he was based in San Francisco, a friend in Baltimore. He didn't want to pay long distance charges. How could we get around that? So he got the idea, well, if there are lots of local bulletin board systems, what if each node, I think at midnight every night, would then sync up with their nearest neighbor, and then that would minimize the cost of long distance, and it might take a while, but then he could send his friend a message for less money. So that started in 1983, and that became my research question. How did it change geographically over time? And then it actually peaks in 1995, and that's a talk for another day. And I guess I was going to have to figure out how to parse some of these nose files. And now this is where the regex thing comes in. Initially, I think Tom actually maintained these node files himself, and then started scribbling things down. You can search for that. It's kind of fascinating. And then it got standardized and updated weekly as diffs. So that's a fascinating thing for looking at how that changed over time. But it didn't quite work worldwide, which is probably because he didn't guess it would get that big. So this is an example of the early format. And you might notice the ones that I've highlighted. So he didn't expect it to have phone numbers outside the US. So that's why there's an asterisk there, and obviously much longer number. Places where commas and spaces were buried a bit. One of the most annoying ones was the England one, which I hadn't found originally, which didn't have a comma, and obviously not a US number. Anyway, so, and the other thing was apparently what finally motivated them to change their whole hierarchy was he hadn't guessed it would be more than 256 addresses in day one. So anyway, they rewrote it, I think, in 1985, and it grew and maximized at about 40,000 servers across the world. Anyway, so I ended up writing this crazy parser, which is a regex. And to give you some idea, each thing had a flag to indicate the state, what the actual phone number was, what the board member names. I had to deal with that awkward England case. And this is how much you can, in Python, have a documented regex, which I can talk about in more detail another time. Anyway, this is what I was then able to model as it grew over time. And that's my silly plot. Thank you very much.
Hello, my name is David. I come from Portugal, and the next DjangCon will be there. And I'm here trying to convince some of you to look at the other side of the pond. So, Portugal is one of the countries in Europe, the closest one to America, by the way. We have direct flights from New York. Any other city you have to get a connecting flight. Porto is a lovely city near the river, Douro River, which is also the origin of one of our famous exports, Porto wine. Why should you come to DjangCon Europe? Aside from the fact that it's another DjangCon, it's a great opportunity to check other DjangCons. Portugal is one of the least expensive countries in Europe, so it's another plus if you want to check out Europe. It will be in May, so you are expected to have spring weather, lots of sunshine and good weather overall. We have wonderful food, and we are famous for Porto wine, and people are really welcoming. So I will show you this video, which promotes basically the venue location of that we will host DjangoCon, but mostly because it will show you a bit more of the city sites. This is actually under construction right now, so it should be finished by the end of October. It's safe to bet that it will be finished in time. The place itself is located in the city center, so with lots of attractions all around. And it's basically in the middle of a garden that has riverside views. So the dates are pretty much closed, but please don't buy your tickets right now because this might change a bit in the next month or so when until we finish up every details. But more information will come soon in the official site, and when we have the full information closed, we will publish it in all the social medias of the user. That's it.
Hi, I'm Elizabeth. I work at Rover. We don't have time to talk about me. We only have time to talk about equality. You might think that this is a talk about the difference between equals, equals, and is, and it's not a talk about is. It's just a talk about double equals. Is of course where things are in memory. There, we're done with that. We don't need 5 minutes. So we all use equal every day. A equals 1, B equals 1, A equals B. It's true. Great. We understand. Maybe you've even seen this. If you haven't seen this yet, now you have, so that's fine. This is the Dunder equals method, and it is a thing that you use to override in a class if you want to compare equals in a custom way. You check how self relates to others. So we're going to make an object that has an overridden equals matcher, and it's true all the time, and one that's non-matcher, and it's false all the time. So matcher equals matcher, and that's always true, and non-matcher doesn't equal non-matcher, and that's always false. So it's great. That's everything makes sense so far. So what if non-matcher equals matcher? That is false. Seems good. They're different objects. I'm okay with this. Are you still okay with this? Matcher is equal to non-matcher. What do we think? Yes, it is true, which feels bad in my heart. Like, you don't want the order to matter. I don't like that equals is non-commutative. That feels wrong and it feels bad. But at least we have a mental model for how equals works, or at least one of the first 4 things that equals equals does. So, are you ready to be more upset about that one? So I'm going to make this thing a subclass matcher, and it inherits from non-matcher, and it returns true on the Dunder equals method, not false like the non-matcher. And so when we compare it to non-matcher, we get true, which is the thing that we thought we would get. But when we compare it to non-matcher, we get also true. So the thing that we just got used to, where it was not commutable, doesn't work anymore. Why is that? Well, it's because it always puts the subclass on the left, first of all, before it does anything else. So you should have really your custom logic in your subclass, and if you don't, please do that, because Python's going to make an assumption that you do. But, so if you're reading the Python data model page, which I suggest you all do, it's a great beach read while you're here in San Diego, and you go down halfway through the page to the rich comparison methods where Dunder equals is, we find out that the reason we're getting such bad results here is because we're really doing things we're not supposed to be doing. We shouldn't be returning false when we're comparing two different things. We should be returning not implemented. So we're going to make this not implemented matcher, and it returns not implemented. That's not implemented error, I want to point out. It's not an error. This is expected behavior. It's just a singleton. So matcher is double equals to not implemented matcher either way, and non-matcher is false either way, and that feels a lot better. It's like we have a consistent thing depending on, like not dependent on which side of the thing we're on. So we now have 3 of the 4 things that double equals does. It puts a subclass on the left, A under equals B, B under equals A if the first one was not implemented. So what happens if we compare not implemented to not implemented? We get false. Now we have a sort of rule 4 where it's false if number 3 is not implemented. But what happens if we save not implemented off to a variable foo and we say food equals food? We actually get true. That's because the last rule is that it actually does an A is B check at the last one. And I actually have enough time that I could have told you about how the non-matcher one will not match if you do an is check, because it won't get there, and that's how we can tell it's the 4th step and not the 1st step. But I cut the slides because I didn't think I'd have time, but I talked really fast. So that's how quality works in Python. Thanks, everyone.
All right. So hi, I'm Ed, I'm a web developer. Part of the work I do involves making sure sites are accessible, and one of the key things to make sure they are is to write good alternative text, and that's what we're going to be talking about today. So I want to introduce some concepts, and we're basically going to be thinking of images in 3 categories. The first one is functional images. This images try to convey to the user that an action will be initiated. They are used in interactive elements like links or buttons, and you can think of them as icons or badges. Then we have informative images. These are images that graphically represent concepts and information. Those are probably the most typical images you think about in a website. They include pictures, photos, and illustrations. And then lastly, we have decorative images. They only add visual decoration. They do not convey any important information to the user, and you can think of them as background images, borders, and other artistic things that designers like to put in websites. So let's go on a guide to see how we can decide which kind of alt text we should enter when facing different images. So these are the 3 guiding principles that are going to be really handy to make sure you write a good alternative text. First of all, you must focus on describing the function or the content of an image. Then it's very important that all images have a defined alt attribute, even if the attribute is empty. You do not want to have images that just don't have an alt attribute at all. We'll see We'll see why next. Then remember that context is super important when describing images, because in some context, defining or leaving the alt attribute empty is the best choice for that image. So you can start by, when you encounter an image, you can start by asking this question: is this image interactive? Then it is a functional image, and you should describe the action or the result that the user should be expecting when interacting with this image. So for example, if I have this markup, I have a logo that is being wrapped with the anchor tag. So this logo is going to take me to the W3C homepage. So the alternative text is the W3C home, because it tells the user where they're going to land when they click the link. Then here we have a little image that is an icon of a printer. And instead of just entering a printer icon, you should say print this page, because it's entering it's describing the action that the user is going to perform when they click the link as well. Now, if an image is not functional, then you go ahead and ask the second question: does this image include content? If it's true, then it's an informative image. You must describe the meaning and purpose of the image. You should avoid literal, super obvious descriptions. You don't need to start with picture or photo in your alternative text. Screen readers are going to tell the user that this is a graphic. And the surrounding context sometimes is enough, and you might not even need to provide an alternative text here. So for example, I have a paragraph here with two images, the little icons, and then the actual value of the phone number or the fax. And if you see the alternative text in the first case it's telephone, and then we have a number. So when this is announced by screen readers, you're going to see telephone 0123, and then fax 0123. And that's much more useful than just saying telephone icon or fax icon. Here we have, for example, a picture of a dog, and we have the paragraph explaining the image, and then we just want to very briefly describe the content of the images, which is the dog with a bell attached to its collar. And here, the image only conveys an emotion or a sentiment. So instead of describing, oh, this is a picture of family outside smiling, we can say we're family friendly because the website tries to convey this information to the user. And lastly, if the image is not functional and doesn't have any content, then it's decorative. We don't provide an alternative text, we just leave the alt attribute empty. And this is back to what I was saying before, that if you don't provide the alt attribute at all, the screen reader is just going to announce the whole URL, and that's going to be a terrible experience for your screen reader users. You're just going to get a huge URL spelled out for them. And when you leave the alt attribute empty, the screen readers are going to skip the image completely. So in this example, the ordered image, just leave it empty, and it's going to be skipped completely by the screen reader. Here, the image is quite redundant, so we simply leave it out because the text in the strong tag is already describing the link. And here we have a description of the image, so it's not really necessary in the paragraph, so we don't need to describe it again ourselves. And yeah, there's some extra things, but we don't have any time. Thank you.